Dear students, I started lecture 18 of Math 304. In the previous lecture, we proceed to solve this sum. At that time, what we did, in the first row, second row, all 5 rows, we select the minimum number of each row and subtract from each element of that row. Likewise, in the another table, what we did, we select the minimum number of each column and subtract from that particular column, and then we reach up to here. Then, as this is a very important things to share with you, this is an assignment problem, as I explained you in the beginning of the previous lecture. Assignment problem is a special case for transportation problem. What I said, cover all zeros by dotted line. Try to draw minimum number of lines and try to draw lines in such a way that at the intersection should not be 0. Means this is intersection at 0 and we should try to do that this intersection should not be at 0, but although it is not possible to do all the time, so we may face some problem. Not only problem, but at that time we lose some zeros at that time. How we lose? Just see here. Now among uncovered, we choose the minimum. I think 15 is minimum. This 15 is minimum among uncovered. Okay, so subtract. Then I add some more notes, more rules. Don't do anything on covered line. Subtract minimum entry from each element, and 6. Add minimum entry at intersection. Don't do anything on covered lines. What we don't want to do, that I will explain. Subtract minimum entry from each element. Add minimum entry at intersection. Means 15 is the minimum, so the next our table will be 15, 0, 20, 15 and 0. 15, 15, 0, 10, 0, 15, 0, 20, 15, 5, 0, 15, 20, 0 and 5, 5, 0, 10, 0, 3. Now we have more zeros. So, what we did, We subtract 15, so it is 50. Don't do anything on line means 0, 20, 15, 0. 15. This is intersection, so we have to add 0. Add the minimum entry means it is 50, 0, 10, 0. 15, 0, 20, 15, 5. 0, 15, intersection is 1 by adding 50. Gone in that way we have less zeros because we want to pass assignment at 0. 20, 0 and 5. We don't do anything on the line. 5, 0, 10, 15 means 0, 0. Let's check 15, 15, 15, 0, 5, 0, 15, 0, 15, 0, 20, 0, 20, 20, 10, 15, 10, 15, 0, 0, 0, 5, 5, 0, 0. Okay. Now whenever there is single 0, we have to select it. Due to that we can't select this. And due to that we have to select this. So rather by doing that it is very comfortable to us that we use a box. Now as we select this, we can't select this. Now whenever there is one option, we have to select, means we have to select this one. Due to that we can't select this one. Due to that we have to select this one. Due to that we can't select this one. Anything written? Yes, this is written. So we select that one. So this will be your answer because we have 5 boxes are there. And therefore the relevant values from the origin, that is 150, 110, 130, 280. So the answer is 570 kilometers. We write this value from the original. Original means the statement which we have given. We write in the initially, we begin with that one, 160, 130. So if you see the statement of the last year, you will find that because we continue this lecture from the previous lecture. So this is 150. Sorry, this is 50. This is 50, 110, then this is 130, 200 and 80. Okay. And the root is A to E, B to C, C to B, B to A and E to D. This is root. And this is your answer. What we are doing? Cover all zeros by dotted line. Try to draw minimum number of lines. Try to draw lines in such a way that intersection should not be at 0, because if it is at 0, we add a minimum entry out of our selection, because it will be not 0 at that time. Don't do anything on covered lines, means we are not in C here, 30, 0. We are not doing anything on covered lines. Subtract minimum entry from each element. We subtract each element, subtract minimum entry from each element. Add minimum entry at intersection. Means we add minimum entry at intersection at both these places, this and this. We lose our 0. Clear? And first we choose this one because on this column there is only 1 0. Each row and each column have 1 0. 1 0 we can select, means we can select this one, so we can't select this one. So now this column have only 1 0, means we have to select this one. As we select this one, we can't select these 2 zeros. If we select these 2 zeros, we can't select these 2 zeros. We can select, we have to select this 0 because there is no other option for this row. And each row and each column have 1 0, one selection, and therefore as we select this, we can't select this one. Now if we can't select this one, we must have to select this one. Therefore we can't select this two. Okay? And therefore we have the solution which we require. Okay friends, we start with one more sum. 40, 35, 38, 41, 42, 35, 34, 40, 38, 34, 34, 37, 39, 36, 38, 36. Okay. Then we select the minimum entry from this row. I think it is 31. Therefore we have to subtract. What we are doing? We select the minimum entry from each row. Then we subtract it from each row. So it is 35 is minimum, so it is 5, 0, 3, 6. Then again 34 is minimum, so 8, 1, 0, 6. Then 34 is minimum, means it is 4, 0, 0 and 3. Then we select 36 as minimum, means it is 3, 0, 2 and 0. 5, 8, 4, 3, 0, 1, 0, 0, 3, 0, 0, 3, 3, 0, 0, 2, 6, 6, 3, 0. Okay. Next, what we are doing? We select the minimum number of each column. Now, except this row, there is always 0. So there is minimum one is 3, and therefore it is 2, 5, 1, 0, 0, 1, 0, 0, 3, 0, 0, 2, 6, 6, 3, 0. Now we have to cover all zeros. This is the last table. I think we covered all zeros. Cover all zeros. Try to draw minimum number of lines. which one will be the minimum? I think 1 is minimum. One, 4, 0, 0, 0, 1, 0, 1, 3, 0, 0, 3, 5, 5, 2, 0. Now select the single 0 if it is there, the single 0. Yes, we have single 0, it is here. Therefore, we can't choose this one. Means we have to choose this one. Means we can't choose this one and this one. Means we have to choose this one and this one. So this will be our answer, and therefore answer 35, 34, 38, 36. Means it is rupees 143. And the route is A to B, B to C, C to A, and D to D. This will be our route, and therefore 38, 35, 34, and 36. This will be our answer. Dear students, this method, just we completed the 2 sums of assignment problem in which we can find the minimum values. Means this procedure is to find, this is special type of transportation problem. Means what we are doing in the transportation problem, we are finding the minimum possible values to satisfy all requirements, means supply and demand should satisfy, and the cost of transportation should be minimum. So this is also of the same type. But what happens whenever there is a maximization? This case is of maximization because we want to find the maximum value, not the minimum value. In the previous 2 sums we did the minimum values, minimum kilometers. But in this sum, we want to find the maximum kilometers. Just think over 1 minute and we solve it. So in this one, what we are going to do? Let me check the statement once more. So 42, 30, 20, 24, 35, 25, 25, 20, 28, 20, 20, 16, 21, 50, 55. Do you have any idea? See here how it is. Obviously you can't, you don't know. But at that time, what we have to do? We have to do the negative of each number. Means minus 42, minus 35, minus 28 and minus 12, sorry 21, minus 30, minus 25, minus 20, minus 50, minus 30, minus 25, minus 20, minus 50, minus 24, minus 20, minus 16 and minus 12. So we are taking the negative entry of each of them. I will continue this sum in the next lecture, but at the same time, I wish you can solve this sum by yourself, because after this, now it is a same problem, because if you find the minimum of this sum, it will be maximum of this sum. So I will continue the same sum in the next lecture. At this time I stop here. Thank you very much.